Welcome. This lecture is called Matrix Multiplication. So we're going to learn about multiplication between matrices, how to multiply one matrix by another matrix. But before we do that, we are going to talk about first we're going to talk about how to multiply a matrix by a column vector. Okay, so this operation is, as an operation, is new, but it involves things that we are familiar with. The first thing to address here, okay, is that we're going to consider matrices that are rectangular. Okay, so that's the matrix that has m rows and n columns. Okay, and this is going to matter because the first thing we're going to consider is a matrix vector product of this form. So here's the matrix A. Okay, and the column vector that multiplies A on the right side, in this case, this vector U, this vector is a column vector, but it has to satisfy that the number of entries on that vector, okay, has to match the number of columns in the matrix. Okay, so if in this case this matrix has more rows than columns, that's okay. The vector that we're multiplying on the right side of the matrix has to have n entries, and so the number of columns on this vector has to match the number of entries on that vector has to match the number of columns on the matrix. So let's talk about another potential case. And another potential case is something that would look like this. This is a case in which the matrix A has these many rows, m, right? And clearly here, m is a number that's a lot smaller than n. So here, for this case, the matrix has more columns than rows, but if we're multiplying the vector u, then this column vector u, has still to satisfy that property, that that vector in length has to match, okay, the number of columns that the matrix has. So how many columns this matrix has is exactly the number of entries in this vector. Okay, so if there are 100 columns, then this vector has to be a member of C100. It has to have 100 entries, if you will. Okay, so that's a requirement for this matrix vector multiplication, that the number of rows, so we're writing A times U, and so the number of columns on this matrix has to match the number of entries on that vector, or it's another scenario as we just draw right there, where the number of entries on the vector matches the number of columns on the matrix. I'm being very specific about this because it's quite important. And so the next thing we note is that the matrix that is at play here for the multiplication has columns, right? So we can refer to the columns. So here is first column, second column, third column, last column, right? So that matrix has columns that we're calling A sub 1, A sub 2. These columns are labeled as A sub 1, A sub 2, A sub 3, all the way through A sub n. Those are the columns of this matrix A. And so there are n of these columns, and this vector u, has n entries, right? So we're assuming that u is a vector that has entries u sub 1 all the way through u sub n. So what's going to happen is that this matrix vector product, it's itself a vector. This is going to be a vector in CM. Okay, this is going to be a vector in CM, and why? You'll see that why. And so that vector results by computing the linear combination. This here is no other thing than a linear combination of the columns of the matrix. Okay, it's no other thing than a linear combination of the columns of the matrix. So what is the case? So remember, if this is the matrix A, here is column 1, here is column 2, here is column 3, and so on. Each of these columns, okay, that is A sub 1, each of those columns, A sub 1, for example, is a vector in CM. You know that there are m entries on that column, right? Well, so that means that that vector is a vector in CM. The second column, A sub 2, is also, you would also say that A sub 2 is also a member of CM, and so is the third column, so is the fourth column, so is the last column. So each of those columns, each of these column vectors, A1, A2, A3, all the way through AN, is a member of CM. They have M entries. You multiply, say, this product, U sub 1 times A1. This is something that looks like scalar times column. This itself is a column vector, right? So that scalar column vector multiplication itself is still a vector in CM. Okay, so this is a vector in CM here. This is an M vector, and so is the second term, another vector with M entries. So is the third term in this linear combination, and so is the last term. So when you add up all those vectors, then you're still, because of properties of closure and the addition, you're still considering a vector in CM. Okay, so this is as far as notation goes. So here, let's notice that this here is going to be the first column. So here, this is A1. This would be A sub 2. This would be A sub 3, A sub 4, and A5, right? And here we have entries. This is U1, U2, U3, U4, and U5. So we're in good shape. There are 5 entries and 5 columns, okay? So we're going to compute the product A times U, and these results by applying that definition, right? So we are writing each of these columns. Here's A1, here's A2, A3, A sub 4, A sub 5, and then we are using the entries of the vector as the scalars. Each of these terms is a scalar vector multiplication. So you carry out that calculation. So this is a simple linear combination, right? So let's see the intermediate steps here. So this becomes, so this linear combination becomes the following, right? So this first scalar vector product becomes 2 minus x2. The second scalar multiplication becomes this vector 4, 2, 6. The next one is negative 4, 0, 6. This product here becomes 9, 3, negative 3. And finally, we have minus 4, 2, and minus 5. We add together those vectors. We get, for the first entry, 2 plus 4 minus 4 plus 9 minus 4, right? So that gives you what? It gives you, say, these two are going to cancel. Then you have 11 minus 4, 7. And then you have minus 6 plus 4. That's, excuse me, minus 6 plus 2. That's minus 4 plus 1, plus minus 4 plus 3 is minus 1, plus 2 is 1, and then we have 6, 2 plus 6, 8, plus 6, 14, and 14 minus 8 is 6, right? So that leaves to these numbers, 7, 1, and 6. So the product of this matrix times that vector equals this vector. So notice also that this matrix has 3 rows and it has 2, 4, 5 columns. This vector is a vector in C. This is a member of C5. It has 5 entries. So we can say that this has 5 rows, 1 column. Okay. So this product here, this product is the product of a 3 by 5 and the product of, you can use parentheses if you will, of a 5 by 1. And so it is important that these two dimensions match. The number of columns in the matrix is matching the number of entries of the vector.